The heat is unbearable, but the fans are off. The sun has set, but there is no electricity still. Electricity lines were drawn here years ago, and yet rarely does any electricity surge through them. And then there are some villages where electricity lines are yet to reach. But we aren't here to count these woes. We are here to find solutions to these pressing problems. Yes, electricity hasn't reached these villages, but there is one thing that reaches everywhere, covering a journey of over 15 crore kilometers every day, the rays of the sun. Yes, we are here to tell you about the power of the sun. So let us begin. We are talking about solar energy, the energy that comes from the sun. To meet the rising demands for electricity, science has developed various types of non-conventional sources of energy. Today, we are able to tap the power of wind, water, and solar energy sources on a large scale to produce energy. Of these, solar energy, that is the energy derived from the sun's rays, is particularly important, as it can easily reach even the remotest of the villages. This is a solar panel. Using this, one can convert the sun's rays into electricity. This electricity can then be used in many ways. The energy generated from the sun is transferred to a battery using wires, through which the battery gets charged. Through this, light loads like battery-operated fans, lights, etc. can be used. Think of load as a technical word, which means all those appliances which operate after deriving power from a battery, which is charged using a solar panel. This energy can be used to teach children or simply to run a fan. Not only this, one can use this energy to cook as well. How? That will come a little later. First, let's learn a little bit more about solar energy. Modern technologies have allowed us to utilize solar energy in various ways. In rural areas, where there is no electricity or it is yet to reach, solar charging stations and solar microgrid types of systems are available. And to utilize this electricity, appliances like solar home light and solar lanterns are put to use. In a solar PV, that is, a photovoltaic system, the production of electricity is dependent on the sun's light. This means that the panels generate more energy during the afternoon and lesser energy during the morning and at night. The current being produced from the panel keeps fluctuating during the day. The rise and fall of the current causes a problem. It affects the charging of the battery. Hence, a device called charge controller is employed in all solar systems. This charge controller is fitted between the panel, battery and load. Charge controller prevents the battery from overcharging and deep discharging. Each battery has a specific capacity. If the battery is used beyond its capacity, then the battery gets spoiled, and then it cannot be recharged using solar energy. To understand a solar PV system, we should learn a little bit more about its components. Let's begin with the solar panels. Nowadays, various types of solar panels are available in the market, such as monocrystalline panel, polycrystalline panel, thin film panel, etc. Out of these, polycrystalline panel is most extensively used. Each panel is made of many constituent cells. Behind the panel lies a terminal box, which has space to connect two wires. The wires are attached in panels using screws or through soldering. The amount of current that a panel can generate depends on its capacity. If we were to see the back of a panel, we'd see few parameters, out of which the capacity is indicated in front of P max, for example, 20 watt peak or 50 watt peak. While joining wires to panels, we should take care of the positive or plus and negative or minus terminals. On the terminal box next to the terminals, one can note that there are separate plus and minus signs. Red wires are for connecting to the positive terminals, while black wires are for connecting to the negative terminals. If many panels are joined, we get an array. This is to say that if we join 4 50 watt peak panels, then we can achieve a capacity of 200 watt peak. When we buy a panel, we should take care of few things. We should only buy certified and tested panels and check the parameters mentioned on the back of the panel prior to purchase. We should also take care that we don't buy a panel bigger or smaller than the required size. Inspection of the panel should be done to check that it's not broken or damaged from any place. Other than sun's light, a panel's efficiency in generating current is dependent on various factors such as temperature, dust on the panels, the direction of the panel and its angle. In India, all panels should be placed facing the southern direction at an angle between 10 to 45 degrees, so that they receive sunlight all day long. Deposition of dirt on the panels can lead to a decrease in the electrical output of the panel. Hence, panels should be kept clean. Solar panels should not be kept in the shade. The glass placed upon the panel protects the panel from rain. Hence, it is not necessary to cover panels when it rains. One panel can operate for many years without any problem, almost up to 20 years. After the panel, the battery comes into picture. The battery is that part of the solar PV system which stores the energy produced by the panel. Each battery has a specific capacity which is expressed in AH, that is ampere hour. For example, 4.5 AH, 7.2 AH and 40 AH, etc. In simpler words, the larger the AH number is, the larger would be its capacity. For example, if we connect a particular load to a 4.5 AH battery and the same load to a 7.2 AH battery, the load with the 7.2 AH battery will last longer than the 4.5 AH battery. Let us now learn about various other types of batteries. This is a lithium-acid SMF battery. This battery is expected to last for approximately 1 to 1.5 years. And after charging it to its full capacity, it can be used up to 60 to 70% of its capacity. It costs between 300 rupees to 600 rupees. There is a problem of deep discharging with this battery. This is a lithium-ion battery. It weighs less than the lead-acid battery, and after fully charging, it can be used up to 80% of its capacity. This battery is durable and lasts for almost 2 years. This is a lead-acid tubular battery. It is also used in inverters. This battery lasts for more than 5 years. It can be used up to 75% of its full capacity after getting fully charged. But this battery requires good maintenance. Apart from these batteries, there are some solar PV systems which use batteries like nickel metal and lithium iron ferrophosphate. Like the panels, we can join one battery to the other to increase its capacity, and this is known as a battery bank. Until now, we've learnt about the components of a solar PV system. Let's now see how to connect them in order to make a solar PV system. While selecting a panel and a battery to form a system, it is crucial to check the voltage and AH of the battery and the voltage and current of the panel. To charge a battery, the voltage of the panel should be more than the voltage of the battery bank. For example, for a 6-volt battery, a 9-volt panel should be used. For a 12-volt battery, an 18-volt panel, and for a 24-volt battery, a 36-volt panel should be used. To estimate how much current is needed to charge a battery, we can look at the battery capacity, that is, the AH. For example, a 4.5 AH battery requires current up to 0.45 ampere. A 7.2 AH battery requires current up to 0.72 ampere. 40 AH battery requires current up to 4 ampere, and a 100 AH battery requires current up to 10 ampere. Even the charge controller is selected according to the panel's current. In case a panel creates 5 ampere current, then the current rating of the charge controller should be at least 5 ampere or greater than that. Rural areas still lack access to electricity, and hence people resort to using kerosene or oil lamps, etc. These sources provide dim lighting, and the smoke and soot from their usage leads to detrimental impacts on human health. In such situations, solar PV system has emerged as a very good alternative. Now that we know a little bit about solar PV system, let's learn a bit more about different types of systems and where they are used. Let us first tell you about solar lantern and task light. Just like a kerosene lamp, a solar lantern too emits light in all directions. But in comparison to a kerosene lamp, light from a solar lantern is much brighter. Task light also functions on the same principles, except contrary to a solar lantern, its light isn't emitted in all directions, but is focused in one particular direction. We can tell whether the solar lantern or task light is being charged by seeing this green LED indicator. Similarly, if the lantern's battery is low, we can tell seeing this red LED indicator. The solar lantern mainly has 4 components: body, battery, PCB, and LED. Battery and PCB are inside the lantern. The PCB, which is inside the lantern, prevents the battery from overcharging and deep discharging. This PCB acts as a charge controller and stores the energy inside the battery. This solar lantern is quite portable. We can take it anywhere, in fields, in the kitchen, to village functions, or any other place. These days, many kinds of lanterns are available in the market. For those areas where people are too poor to buy these lanterns, a different system has been set into place. This system is called a solar charging station. In a solar charging station, many lanterns can be charged simultaneously. One person from a village is chosen as an entrepreneur, at whose house a solar charging station is set up. The lanterns are charged over the course of the day, and by evening, the entrepreneur delivers them back to the villagers. For this service, the entrepreneur charges a nominal fee from the villagers. This fee becomes a source of income for the entrepreneur and helps in the upkeep of the lanterns and the solar charging stations. A solar charging station is designed to charge around 10 lanterns. If the requirement is higher, in that case, more charging stations catering to 10 lanterns each can be set up in different locations or in the same location itself. In a 10-lantern solar charging station, there is one 50-watt peak panel, which is connected to a junction box through wires. A 50-watt peak panel produces a current of 12 volt and 45 ampere approximately. But this electricity cannot be provided to the lantern directly. A junction box can limit this voltage and current and bring it to 0.5 ampere and 9 volt, which is suitable for charging the lantern. Other than this system of solar charging station, there is another model called solar microgrid. In a solar microgrid, we can bring a panel of 75 to 150 watt peak or higher into use. In a solar microgrid, instead of a lantern, fixed light points are used. The panels used in a solar microgrid are attached to a charge controller through wires. Through a charge controller, current goes into the battery. We also attach a DC distribution box to the charge controller. The current travels through this DC distribution box through wires and finally reaches homes. We use this current to use 1 to 3 watt LED bulbs. Just like solar charging stations, a microgrid can also provide light to 10, 20, 30, 40 or 50 households. If we require electricity for 10 houses, we require a 12 volt and 75 Ah battery. We would also require a 75 watt peak solar panel. If we want to create a solar microgrid for 40 households, we require 24 volts and 150 Ah battery bank. We would also need an array of 300 watt peak. Compared to a solar charging station, a solar microgrid requires lesser maintenance. There are some fundamental differences between a solar charging station and solar microgrid. From a solar charging station, we get a solar lantern, which is portable, while solar microgrid provides electricity directly to your homes. If one is to utilize the electricity from a microgrid, one can use it only at home. Solar energy can be utilized in the household levels in more ways, such as by using improved cookstove, home lighting system, and IDES system. Now, let's talk about the improved cookstove. Traditional mud stoves produce life-threatening smoke. In India, nearly 5 lakh women succumb to the poisonous fumes of mud stoves every year. But in places where the improved cookstoves have been deployed, lesser incidents of respiratory problems in women and children have been reported. The improved cookstove prepares food in shorter time, hence saving a lot of time for the women for other work. In an ideal improved cookstove, locally sourced fuels such as wood, dung cakes, and agricultural residues should burn fully without producing smoke. Improved cookstove not only utilizes fuels efficiently, but maintains the temperature of the stove also. There is a small fan fixed inside the improved cookstove, which runs with a battery that is charged either through solar power or electric grid. The white cylinder fixed inside the stove is made of a material called white heat K, which maintains the heat or temperature inside the stove. The fan fixed inside the stove allows air to flow from the holes in the cylinder, which causes wood to burn without much smoke. In fact, wood that is not completely burnt also burns fully due to the air that comes through the upper holes on the stove. The body of the improved cookstove can be made of either metal or mud. Also, the speed of the fan can be controlled using a regulator, which can be used to either increase or decrease the flame.
देखिए हम आपके गांव में एक चूल्हा लेकर आए हैं जो ये सोलर से बैटरी चार्ज होती है और इसमें कम लकड़ी लगती है, 2 लाइट जलती है साथ में और एक मोबाइल चार्ज होता है.
Let us now talk about IDES system, which stands for Integrated Domestic Energy System. It can be used for both lighting purposes as well as stoves. IDES uses lithium-ion or tubular batteries. We can attach LED bulbs to this system and also use it for recharging mobile phones. Like IDES system, there is also a solar home light system. The only difference is that it doesn't have the provision to operate a cookstove. So, now you know about the wide possibilities through which solar energy can light up your village. Hope you will get started soon.